Hi, I'm Dr. Brad. We're continuing this talk on Lyme disease. This one's going to be on barriers to healing. So we look at it, the history of Lyme disease, a lot of people are pretty aware of that. It was some young people that started getting strange arthritis out in Lyme, Connecticut, which is just across the breezeway from Plum Island, which was an animal research center where they were doing a lot of biological research over there. And whether the Plum Island issue is a reality or not doesn't matter so much in the fact that that's when we became aware of it. The interesting things about this is the same year that the disease was discovered, they had no idea what was causing it. The CDC, it comes out with treatment protocols of 2 weeks antibiotics, and that should take care of it. It's not till 2 years later they find out the black-legged tick was the carrier of it, and that's the deer tick in some areas, black-legged tick in other areas of the country. And it's not till 7 years after the disease started they actually figured out what was causing it. And I don't know about you, but to me that seems completely backwards. Any thinking mind should think, well, wait a second. You shouldn't come up with a way to be able to address things till you know what's going on. Anybody good at anything has to be able to define what's going on in the problem before they can address it. And this is totally backwards with this disease. It just does not make sense. And the funny thing is, once they figured it out 7 years later, they never changed the treatment protocols for it. And the CDC pretty well directs the way that Lyme disease is addressed all over the world. I don't know why they have that kind of authority, but they do. So when we started looking at some of the realities, this Nina Zubacek, she was the Lyme liaison for Harvard. She was visiting Martha's Vineyard Hospital, and she says a few things that are really, really key for us to know and understand. Conception of tick has to be attached for 48 hours is pretty much completely outdated. Studies show that attachment of 15 minutes can give you anaplasmosis, 10 minutes for Powassan virus, and for the different strains of Borrelia. They have no idea. And everybody wants to use the Burgdorferi strain of Borrelia to do all the testing on it. When Burgdorferi was never found in a human, they isolated it from a tick. They got it down to what they thought was one of the bacteria grew that, and did all their tests off for that. They don't even know if this is an infectious agent. They don't even know. They know it was in ticks, but they don't know if this is what causes anything. And they're at first time of looking at how many strains of Borrelia there were over 100 strains when they first looked at Lyme disease. Several years back, looking at it, there were over 300 strains, so I have no idea how many are out there because the labs that can find these things don't give access to people like me. They just hide it. So when we look at it, at last looking, Borrelia is a corkscrew type of a bacteria. Over 300 strains the last time I looked, now several years ago, and I just can't find any information about how many more. Only 30% of the people at the most get a rash, some say 20%. 99% of the tests use B31. 50% of the tests are negative. The Western Blot's the longest duration of a test that can be used. Most of the tests are 1 to 2 weeks after infection. The Western Blot is 6 to 8 weeks after infection. After that, it has no clinical accuracy whatsoever. Borrelia is a close cousin to syphilis, which would have been a really good thing to in a general sense, to hot rod up if you're really looking for something to destroy a population. It mutates very quickly, it moves out of the blood quickly, it can swim against the stream of the blood, it outswims the fastest of our white blood cells. It can copy your protein and cover itself very quickly like a shell, and say one of the white blood cells is chasing it upstream in your blood. The Borrelia can just go right through the vessel wall, the blood vessel wall, corkscrew itself into the tissues, copy the tissues, cover itself over, and in a very short period of time, the immune system just recognizes it as us because it's got this shell of our proteins over it. When it's threatened, it makes a biofilm, and new research is making it sound like that may just be a general life cycle. It can stay in the biofilms for up to 17 years and break out. They can come in and out of the biofilm and feed. They actually interlace themselves, much like a mat, and create this matrix that goes in it where in things that would come to attack it can't get to it. Antibiotics can't get through the biofilm. Your immune system can't get through the biofilm. It can just stay in there, create its toxins, pollute everything. When those biofilms are fixed, it stays there. If they're floating, that means they're inside of the bloodstream. They're broken loose. It's like an embolus that can cause a stroke, a heart attack, or kill somebody fairly easily. The bacteria communicate inside of those biofilms and multiply readily inside of them too. So we look at some of the things that Nina Zuba said. She says she was a Lyme liaison from Harvard talking at Martha's Vineyard Hospital. With current testing, 69 out of 100 patients that have Lyme disease can go untreated because the tests are false. Bullseye rash happens only 20% of the time, and it's all over the map on how many times this happens. It's not a very good indicator. As I said earlier, it swims twice the speed of a white blood cell. Doxycycline, this is the biggest one. Doxycycline, it doesn't kill the bacteria. It's only trying to help stop it from multiplying. It's a critical thing to know. This is the Harvard liaison for Lyme disease, letting us know the antibiotics, the number one antibiotic used, isn't doing what people think. It's not killing the Lyme bacteria. It's trying to keep it from multiplying. It's up to your immune system to try and overcome it. We look at the next thing in Lyme disease, Babesia, is from my own clinical observations. It is the biggest of the co-infections. In many, Babesia is a worse issue than Lyme disease itself. When people are getting high fevers, you can basically figure Babesia is there. If their blood work starts to show irregular blood cells, if they're starting to show some anemia, that's an indication Babesia is there. They just can't find it. The lab tests are terrible for this stuff. When I first looked at Lyme disease, there were around 30 strains of Babesia identified. When I last looked at it several years back, it was over 100 strains. An interesting thing about the Lyme bacteria, in light of this, there's 30,000 potential different genetic variations. That's 30,000 potential different strains. Now, how many are out there? It's hard to say. You just keep mutating. Babesia can do the same thing. There's 3 lab tests for Babesia, 2 are illicit tests. Those are the antibody immunoassay tests, which are atrocious as far as their accuracy goes. We'll go through that in a bit. And one blood smear. And if you think about it, in a blood smear, 1 drop of blood has about 5 million blood cells in it, something like that. And whenever anybody does a blood smear, the lab technician counts the first 100 cells they see. If they're out their lab, they might do that 2 or 3 counts. Well, the likelihood of finding these parasites in some of those cells is really, really, really small. Really small. Ehrlichia is the next one. Ehrlichia is a bacteria that invades the white blood cells. So white blood cells, your immune system, Ehrlichia destroys immune function. It's a bacterial parasite. It can live inside the white blood cells that should be killing it. It can live there at last. Looking, there are at least 26 different strains, 2 tests that are illicit tests. Those tests only get value the first 1 to 2 weeks after infection. Nobody knows they even have it then. That is incubated enough, and by the time you go in to look at it, there's no accuracy left in the test. But BC is pretty much the same way. Rickettsia, at last look, which was just a little while ago, nobody will give a count on how many strains are in it. I had to count some of the articles out of the governmental sites to see how many strains I could count, and the biggest number I got out of any single article was 23 strains. So that's where I come up with that. This has 2 illicit tests that have somewhat of an accuracy in the first 1 to 2 weeks of infection. After that, the accuracy falls off like a cliff. So we look at anaplasmosis. No way to test this because anaplasmosis is a reaction. It's not a type of bacteria. And the reaction, you can see all the pink granule types of things. That's what anaplasmosis does. It causes these granular types of inflammatory deposits in different cells and different tissues, and it makes them so they're totally dysfunctional. So anaplasmosis is more of a reaction than a certain class of bacteria, and it's like it's impossible to even test. And it's impossible to count how many bacteria do it because all they see is the reaction. They don't know who's causing it because it's wide and it's varied. Then we got the Powassan virus. The Powassan virus, is transmitted by ticks. It is one of those tick-borne diseases. When we look at it, the biggest vulnerability for this is the upper Midwest. In over a 10-year span, they had about 75 cases of this. So it's not something that people have to be that concerned about. It's not that big of a factor in the Lyme disease. A lot of people are really concerned about it, but not that big a factor. This is one that really amazed me, the alpha-gal allergy issue. This was something that was common several years ago. The alpha-gal idea came from some scientists out of Russia. There's a scientific team that's trying to do some research on cancer, wanted to get themselves famous. They couldn't find anything with cancer, and during the course of their studies, I believe it was 2 of the people in the team that came down with Lyme disease. And they started doing some studies with this, and they did a really interesting experiment. They took some meat juice. So, nothing specific. They took some meat juice, did a skin prick test on it. It reacted the same way when you get the skin prick test for allergies, called a RAS test. It reacted the same way. So they wrote up these articles, they printed them in the newspaper about their great finding, and they extrapolated that this redness had to do with the sugars inside of the meat causing the allergies, and they claimed it to be a IgE allergy. Well, no one did any of the research. As far as that goes, nobody isolated this sugar out of the meat to clarify it. No one did any of the assays to clarify whether this was IgE. It was a total visual test off a skin prick of something. I mean, you think about a meat extract. It's got blood cells in it, it's got meat cells in it, it's got protein in it, it's going to have some connective tissue in that. It's going to have some of the food or the meat, and how do you isolate one of those with a general meat extract? It made no sense to me, and then they published a little bit more, and they never really got into the definitive studies to make this into a reputable journal. They published it like most junk science is into social media and in newspapers and things along that line. So this really never was that big of a factor. It was never something that was substantiated very well. It became big press for a couple of years and just kind of blew over. And this goes along with some of the things that we were talking about with Mark Hyman and all that, where the amount of research that's put out there and given to people is just falsified information, a whole bunch. And it really never made it in any reputable journals anywhere, just published out of the newspapers in Russia, and other places picked it up just looking for a story, but it kind of blew over after a while. So these are some of the factors that really are standing in the way of people getting healed. People are chasing different stuff, and when we start to look at the reality of the labs and all that, I'm going to get into that a little bit. They're atrocious. Yeah, that's right. The accuracy of labs is not anything what people would ever expect them to be. 0 to 20%. You really can't hang your hat on a therapy that's directed by an accuracy of 0 to 20%. Just